Hello, welcome to my YouTube channel. If you are new to this channel, please hit the subscribe button so that you get notified when content like this is uploaded. In this video, we are going to look at a previous question paper which was written in March 2026. The question paper is for the grade 12 physical science and is from the Department of Education in Free State. Without any waste of time, let's get right to it. The first question that we always get in physical science is a multiple choice question. When you are answering the multiple choice question, you should only select the correct answer and you are provided 4 possible answers. So you need to understand theories for you to be able to understand these questions. I'm going to try to explain the concept in each and every question so that you get a better understanding of the selection of the answers. So the first question says, an object will remain in its state of rest unless a net force acts on it. So now, from that statement, we already have an idea to say they're actually talking about Newton's first law. Because if you were to state Newton's first law, it says that an object will remain at rest or it will continue to move at a constant velocity unless it has an unbalanced force acting on it. So now they only included the first part whereby the object will remain at rest unless there is a net force acting on it. So that simply means it is Newton's first law. So the question says now we must choose which law best describes this statement above. From that, we already know that, okay, the answer should be A. So if we look at the second question, it says that an object's acceleration due to gravity on planet is g. What is acceleration of another object with double the mass on the same planet? So now, if we are all in one planet, for example, let's say now we are all in Earth. We know that the gravitational acceleration of any object in Earth is 9.8 meters per second squared and is always acting downwards. So this means for any object, no matter how big it is, no matter how small it is, if we are in the same planet, we are going to experience the same gravitational force. So in this case, if you double the mass, if you triple the mass, if you even multiply it by 100, the gravitational acceleration will still remain the same. So on the question, they said now, the acceleration of the object due to gravity on that planet is g. So if we double the mass, that means the acceleration will still remain to be g. So this means the best option is going to be B, because the acceleration will just remain g, will just remain the same acceleration. 1.3 says that two objects collide from opposite direction. Which statement or law always apply? So now, if we have two objects that are collecting or colliding, we are going to always get a force together with a reaction force. And that means we are talking about the Newton's third law. So now, if body A exert a force on body B will simultaneously exert a force on body A. So now, every time when you talk about contact forces or whatever that has to deal with one object colliding with the other, we know that the law that will be involved there is going to be the Newton's third law, which says that for every force applied on the object, that object will simultaneously apply the same amount of force in the opposite direction. So from this case, we are going to say now, the answer should be the third law, because now the third law says for every action, there is a reaction. So every time when we have objects that are colliding or that are in contact, we know that the law, which is third law of Newton's, will always apply. We're going to have a force and we're going to have the reaction to that force with same magnitude but opposite in direction. So the next question that we have, it says that two objects, A and B, having a collision while moving on a straight line. During contact, object A experiences a small explosion. Choose the correct combination. So now we are actually having two objects. Let's say we have object A and we have object B. So when this object meet at this point, they are going to have a collision. But now the statement says object A experiences a small explosion. So that means now there's going to be explosion. So explosion simply means that there's going to be energy that is released. It's either released from that object or it is gained by that object due to the explosion. So when that happens, what is going to happen now? The statement, we have to choose now a suitable statement. So statement number A, it says the total kinetic energy before and after collision is conserved. So remember now, before the collision, we will have now the kinetic energy of the object as being whatever it is before the collision. But now if you look at object A, after the collision is going to experience an explosion. So if it experiences the explosion, that loss of energy or gain of energy, it is going to actually affect the kinetic energy of object A, because if something explodes, it either gains the speed due to the explosion. That means now during the explosion, body A is going to gain speed, and that speed actually makes body A to move faster. And that means now what we're having there, we are having more kinetic energy. So kinetic energy before for object A is going to be less than kinetic energy after because of that explosion. So that means now number A is not going to be correct. So if we look at number B says kinetic energy is not conserved. So with this statement not conserved, we agree with that statement. But now there is also another second statement that says conservation of momentum. That means momentum is conserved. Remember now, conservation means momentum is conserved. So let's also try to analyze the momentum. So especially for object A, remember now, if object A had a particular momentum, that momentum simply means we have mass multiplied with velocity. So during the collision, the momentum, it would have been conserved if we had no explosion. But now because of the explosion, the object A has gained a particular kinetic energy. That means the velocity would change, changing now the momentum of object A. So in this case, the conservation of momentum is not going to apply because it will not be conserved. So now that means number B is not the correct solution. If you look at C, it says total kinetic energy before and after is conserved. We know no, that is not the correct answer. So that means we are going to be left with now D as the solution, because now D simply says the kinetic energy before and after is not conserved, and then also conservation of momentum does not apply. With what I've just explained, that will make D to be the most suitable answer to 1.4. So that means we're going to highlight now to say the answer is D. So now as we move to the next question, they say now, a man sitting on the edge of a roof throws a small ball vertically upwards. When the ball comes down, he misses the ball and the ball falls past him to the ground, where it bounces and then reaches a maximum height at P. So with this statement, we should now answer question 1.5 and question 1.6 on that scenario. But now there is an important statement that says now we must take up as positive. Please don't neglect that statement, because now we know that up is positive. That is very much important. So if we look at now question number 1.5, it says that at point P, the acceleration of the ball is. So now remember, now this is a projectile. At any point, the acceleration of the ball is going to always be 9.8 meters per second squared, but it will be acting downwards. So now if it is acting downwards, that means we have selected, or we are told to take up as positive. So that means down should be negative. So the acceleration should be negative 9.8 meters per second squared. So the solution to 1.5, it should be number C, which says that we have the acceleration, which is 9.8 meters per second squared downwards. That negative indicates downwards. So 1.6 says that during the collision of the ball with the ground. What is it that is happening during the collision? We don't know. They say now, number A, was the momentum of the ball increased? Okay, so now let's try to analyze what is happening during now a contact of the ball and the ground when it bounces. So now when the ball hits the ground, remember now it is going to come with a high velocity. So that means now the velocity here is going to be a high velocity. But now after it bounces from this, it is going to leave to go up with a less velocity than the initial velocity, because during the contact there is a loss of energy due to sound or due to other effects of energy. But now the velocity after the bounce is not going to be the same as the initial velocity. That is why you see now after the ball bounces, it does not reach the same maximum height. It just reaches now a smaller height than before. It is because it has lost energy due to that contact. So the first question says the momentum will increase. So this is incorrect, because now the momentum when it comes is going to be bigger, because the velocity is bigger when it comes to contact. But now when it leaves the surface, the velocity is going to be smaller. So this means now the momentum after will be smaller. So the momentum will decrease, not increase. So that means now A is not the solution. So number B says was no net force acting on the ball. So now this is incorrect, because now during the contact, the ball is going to put a force onto the surface, and also the surface will simultaneously apply the same amount of force on the ball. So there is a contact force during that bounce. So that means now the statement is incorrect that says there is no net force acting on the object. There is going to be a net force there. That contact force, there's going to be a net force there. So now the next statement says that was the total kinetic energy not conserved? So this statement is correct, because now the kinetic energy initially is going to be higher since the velocity is higher, and then the kinetic energy after is going to be less, because the velocity will be less after the collision. So this statement is correct. The kinetic energy, it is not conserved. It's going to be different, because now we have different velocities before contact and after contact. So that means now number C, it is the correct answer. But now let's also look at maybe what statement number D will say. It says that is the force of the ground on the ball smaller than the force of the ball. This is incorrect, because now remember now during contact we have now Newton's third law. If the ball exerts a certain amount of force on the ground will exert the same amount of force on the ball. So the only solution here is only number C. So now As you continue, we have now 1.7, which says we must consider the following condensed molecular formula. So normally when I get condensed molecular formula, or when I get a molecular formula, what I like to do, I would like to actually represent it as a structural formula. Because if it is a structural formula, then I can clearly see what is actually happening on that formula. So let me just write this as a structural formula. So we have the first carbon that is having 3 hydrogens. We have now the second carbon with 2 hydrogens. The third carbon with also 2 hydrogens, but now it is also connected to hydroxide. So from this, I can clearly see now I'm having an alcohol, and the name of this thing is going to be propanol. Okay, so now the question says, what is the name of the functional group found in the above molecule? So now remember, now the functional group of alcohol, it is represented by this OH. So the OH, from the OH, you can clearly see now you have hydrogen and oxygen. So the name of that functional group, we call it hydroxyl. So this means the suitable answer here, we're just going to say, okay, this is just going to be B, because now this is hydroxyl. The alcohol has what? Has OH, which is a functional group. So the name of that functional group is hydroxyl. So as we move on now to the next question, they say we must consider the organic compound below. So if we look at this organic compound is actually an ester. But now we know an ester is actually a product of an alcohol and carboxylic acid. So before we can even answer the question, we can just try to identify what is the alcohol and what is the carboxylic acid. So whenever the ester is formed, that means now on the part of oxygen, on this oxygen in between is going to actually separate what is alcohol and what is carboxylic acid. So we can clearly see that on the left, we just have now alkanes. That means now we just have a carbon with hydrogens. So this means this part that is not having a double bond oxygen, that will have to be the alcohol. And then the part that has this double bond oxygen, it will have to be a carboxylic acid, because on the functional group of carboxylic acid, we have that double bond oxygen. So that is what we know. We will look at how this esterification is formed on another video. So now with that being said, let us now try to answer the question. The question says, which one of the following pairs of reactants can be used to prepare the compound in the laboratory? So we know that compounds will be what? It's going to be alcohol and carboxylic acid. So we can just answer this ourselves before we look at what we have on the diagram. So we can clearly see now the alcohol is going to have what? It's going to have 2 carbons. So remember now, if we have 2 carbons, we know that is eth. So that means that is the alcohol will be now ethanol, because now we have 2 carbon on alcohol. 2 carbons means eth, and then the OH will simply means that it's going to be an ethanol. So on the other part here, how many do we have? We have now 1, 2, 3 carbons. So that means now the carboxylic acid, it consists of what? Of 3 carbons. So 3 carbons simply means that is going to be a propanoic acid. Propanoic acid. So we're going to look at the option that has ethanol propanoic acid. I mean ethanol and propanoic acid. So if you look at our number A, we have ethanol and propanol. Remember now this propanol, that makes it to be an aldehyde. But now we are looking at what? At alcohol and carboxylic acid. So number B, we have now ethanol and propanoic acid. So this should be the correct answer, because now we have now ethanol and propanoic acid. So if we also look at number C, ethanol, what is ethanol? Ethanol, that one is an aldehyde. So that should not exist in this reactants of ester. And then also number D, ethane. Ethane is an alkane, and that is not going to be a part of the reactants of an ester. Okay, so that means now the only solution to that problem is only number B. So now 1.9, it says that which one of the following sets of compound show in order increasing strength of intermolecular forces. So now we must look at these options to see now which of these is actually correct in comparing the strength of intermolecular forces between different homologous series. So number A, we have now chloroethene. So what is a chloroethene? Chloroethene, that thing means what? We have now a haloalkane. So on the haloalkane, number A, we know that we have what? We have dipole forces as the stronger forces. Dipole. Okay, so now if we look at ethane, ethane is London forces. So already now this is going to be incorrect because now they are saying now the dipole are weaker than the London forces. You see now they say now the dipole are weaker than the London forces. We don't have to look at what comes after that. So this statement is going to be incorrect because they say now the strength of what? Of the haloalkane is weaker than the strength of an alkane. That is incorrect. So if you look at now the second statement, they say we have now ethanol. So now we know on ethanol what we are having, the strongest intermolecular forces there is going to be the hydrogen bond because that is a alcohol. So they say now the hydrogen bonds are weaker than the chloroethane. So remember now on chloroethane is a haloalkane, we have now dipole as the dominant forces. So now this is going to be incorrect because now the dipole forces should be weaker than the hydrogen bond because the hydrogen bonds are the strongest intermolecular forces. So this means also B is incorrect because now that is incorrect statement. We can't say now hydrogen bonds are weaker than dipole. So if we look at now number C, they say now ethane, which is now London forces. So we know that that is an alkane. We have London forces. Okay, they say now London forces are weaker than ethanol, which is now alcohol. So we have now hydrogen bonds. Okay, so that first part is correct. The first part is correct because London forces are weaker than the hydrogen bond. But now lastly, they say now also alcohol should be weaker than the chloroethane. So chloroethane, that means what we have? We have now a haloalkane. So we have now dipole. So now this is going to be incorrect because now the dipole should be weaker than the hydrogen bond. Hydrogen bond can be weaker than the dipole. So that also makes the statement of C to be incorrect. So without even looking at D, that means D should be correct. But now let's analyze what is happening on D. So on D, we have now the first or the lowest intermolecular forces as ethane. Ethane, what do we have? We know ethane is London forces only there. And then chloroethane, what do we have? We have dipole forces. And we know that London forces are weaker than dipole. So the first two are correct. And they say now we have ethanol. So the dipole are also less than the hydrogen bond. So this statement is going to be correct. We have the weakest as London, the second weakest as dipole, and the strongest as hydrogen bond. So this means now D is the best solution to our problem. So now if we look at now the last multiple choice that we have, it says that an organic reaction takes place between ethene and chlorine under suitable conditions. The product that will form is. Okay, so now remember now when we talk about ethene, we talk about now we have two carbons, but we have double bond because now this is an alkene. So we're going to have now this ethene reacting with what? With now a chlorine. So now chlorine simply means we have now two two chlorides. Okay, so now what is happening now? If this thing react, we know that what is going to happen. If we have suitable conditions, that means this double bond is going to break. And then when the double bond breaks, what is going to happen is that we're going to have now this ethene tending to have a single bond, and we have those hydrogens there initially that were there. But now the bond that was in between is just going to have now a space whereby it can actually bond with other things. So now remember, now we have two chlorines in this case. So that means now one chlorine will be attached to this carbon and the other chlorine will be attached to that carbon. So this will be the product that we have. So now they say now, we should pick now the name that best describes this product. So from this product, we can clearly see now, okay, we have now a haloalkane. But now on the first and on the second carbon, we have now the chlorine. So that means we're going to say now we have now 1,2 dichloro, and then we have 2 carbons. That means it's going to be dichloroethane, because now we have now the single bond. So we're going to look at 1:2 dichloroethane. So if you look at the options that we have, the first option, they say 1:1 dichloroethane. So this is going to be incorrect. It will be a product, but it's not a suitable product under good conditions. Under good conditions, what is going to happen is that one chlorine will form with that carbon, and then the other one will form that one. If the conditions were not suitable, what is going to happen is that this one of the hydrogen will go to the other bond there, and then it form that product that we have, 2 chlorines on 1 carbon. But that does not happen in most cases. So the first thing that happens is that when you break the double bonds, those 2 chlorines that were acted to that ethene, they're going to go directly to those single bonds, each of them, and then they will form that. So that means number 1 is not correct, but it can be correct sometimes. If we don't have any other option, then number 1 is going to be a suitable if we don't have any other option. So now if we look at number 2, they say now we have 1:2 dichloroethene. So now look at the mistake is now is the ethene part. So this is no longer now an ethene, but is an ethane. So that means now B is incorrect. So if we look at C now, they say now we have 1:1 dichloroethane. Okay, so now this thing, okay, number 1 is gonna be completely incorrect. So what I meant is actually number C is incorrect, but it might be correct in other suitable conditions. So the first one here, this is totally incompletely incorrect, because now we have that ethene there. How can we have now the chloros and then we still have the double bond there? That does not happen. Okay, so now if we look at now the last option, they say we have 1:2 dichloroethane. So this is going to be the suitable answer, since we have what? We have 1:2 dichloroethane, ethane, which is this part. So D is the suitable answer to 1.10. So now that we are done with question number 1, we are going to start with question number 2. Question number 2 that we have now is Newton's laws. So the question says that a block of mass 15 kg rests on a rough inclined plane that makes an angle of 30 degrees with the horizontal, as shown in the diagram below. So we can clearly see that here we have that object 15 kg, the surface, it is having an inclination of 30 degrees from the horizontal. So they say that the block experiences maximum static frictional force before slipping down. Okay, so now what is a static frictional force? So a static frictional force is the force that you need to overcome if you want to move an object. So now that means now if the object is remaining on a rough surface, so you need to push this with a force that is bigger than the static friction. Otherwise, the object is not going to move. So that is what the static friction means. It means now the object is at rest because the force is not of the the static friction is not actually overcome. Okay. So now, the first question now, it says us we should define now the term static friction. So now the static frictional force, if you define it, you should say that, okay, this is the force acting parallel to the surface. Remember now, the frictional force will always act parallel to the surface. And then at the very same time, it will oppose the motion of the object. Okay, it opposes the motion of the object. But now, in this case, you should mention that it opposes the motion of an object that is stationary, because now the static means now it is not moving. So that is how you would define a static friction. But please just use the exam guideline to check the correct definition that is most suitable for you to apply on the exam. So now we can now answer now 2.2. They say we must draw a labeled free body diagram showing all forces acting on the block. So we know that every time when we have a block, we are always going to have the gravitational force. So the gravitational force will always be acting downwards. So on this object, we don't have any force applied, but now we are told that this object is having a static frictional force. So that means now the static frictional force, it is going to go up, because as you can see now, this object will want to go downward, but now it wants to slide, but it can't slide because the surface is actually rough enough. So this means now what is happening, the static frictional force, it is actually going in the upward direction, and then we have the normal force that will be perpendicular to the surface, and it's always perpendicular to the surface. So you can see now on the free body diagram we have three forces, and then also if you look at the mark allocation, it says we have 3 marks. So most of the time you should always refer to the marks to check how many forces you should have. So this is our free body diagram. So now we're going to move on and answer 2.3. So on 2.3, they say we must calculate the coefficient of static friction acting on the 15 kg block. So after you draw this free body diagram, it will be very much important for you to indicate the component forces of the gravitational force, since you are having this object as an incline. So remember, we're going to take the horizontal dimension as the forces that are parallel to the surface, and the vertical dimension as the forces that are perpendicular to the surface. So we are going to say now this gravitational force is going to have now the perpendicular force going in this direction, which you're going to say this is gravitational perpendicular, and it is also going to have now the horizontal force, which will say now this is a gravitational force parallel to the surface. So now this thing, you don't have to indicate them on your free body diagram. I'm just indicating them so that I can be able to do the calculations. If you wanted to represent now your free body diagram with component forces, what you should represent it like this is going to be now your static frictional force, your normal force. But now, if you use component forces, you are not supposed to put the force of the gravitational force. So you will say now you have now the FG perpendicular and the FG parallel. It is best to work with this diagram because now you have now the forces on the dimension that you will work with. Okay, so now the first question says we must calculate the static friction. So remember now, for us to be able to calculate the static friction, we need the frictional force, because now the equation of the static friction, it says now is the coefficient of friction multiplied by the normal force. So what do we need to calculate this coefficient of friction? We need the frictional force. We also need the normal force. So this means we must use our free body diagram to actually get the frictional force and to also get the normal force. So if we look at our object is not moving in any direction. It's not moving horizontally to the surface because it is static. We have static frictional force, is not moving. It is also not moving in the vertical dimension. So this means now the force on the horizontal dimension are balanced because there is no acceleration. So we will say now, we look at the first horizontal dimension to say now, the net force on the horizontal dimension is equal to 0 since we don't have any acceleration. But now you should be able to choose the specific direction. So if you choose down as positive, since this object is tending to go down, you can choose down as positive, or you can choose up as positive. It is really up to you. So I'm going to choose now down as positive, and I'm going to choose this frictional force as a negative direction. So now when I do my net force, I'm going to say this is going to be now weight parallel minus the static frictional force, that is equal to 0. So this means now when I transpose, what I'm going to have that the static frictional force is actually equal to the gravitational force, but the parallel one. So now what is the parallel component of the gravitational force? So every time when you have the parallel, you should use the following to say now, okay, the FG parallel is equal to FG multiplied by what? Multiplied by the cos, not the cos. If it is parallel, you use the sine of theta. So you use the sine of theta for the reason that you are going to use the angle that is the angle of inclination to the surface. So let me just try to explain why you use the sine of theta. So if we can just extend this free body diagram, you will see that the angle that we have is going to be 30 degrees here. So this angle of 30 degrees is going to be the same angle as the 30 degrees there. So now if we look at this, if we look at the FG parallel, which is this part here, it is actually opposite the angle. So remember now, if you have the opposite and the hypotenuse, the opposite and the hypotenuse represent the sine of theta. So that is why now, if we say now the opposite force was the gravitational force parallel, which is in this case FG parallel, all divided by the original gravitational force, you will use the sine of theta. So when you cross multiply, you will get that the FG parallel is always the FG multiplied by sine of theta. So you don't need to understand that theory. What you need to remember is that for FG parallel, you use what? You use the gravitational force multiplied by sine of theta. And therefore, for FG perpendicular, let me just erase here and put it here at the bottom. So remember now we had the static friction is equals to FG parallel. So, but like I was saying now, for FG perpendicular, you should always use what? The FG cos of theta. If you can just memorize these two equations, especially for inclined plane on physical science, then you should be okay. So, like I said now, we said that the static frictional force is equal to the FG parallel. So now we're going to say now the FG parallel is actually given by the gravitational force multiplied by sine of theta. This theta is the reference angle, and that reference angle is the angle of inclination of the surface. So we're going to say FG is actually m multiplied by g. So what is the mass of the object? The mass of the object was actually 15. So we're going to say now FG is 15 multiplied by 9.8. That is the gravitational force, the weight. It is what? It is mg. And then we have to multiply this with what? With the sine of the angle, which in this case, the sine is 30 degrees. So we should now get the static friction by looking at that horizontal dimension. So if I can punch on my calculator, 15 multiplied by 9.8 multiplied by sin of 30, we are going to get that the static frictional force is 73.5 newtons. So that is going to be the static frictional force. Okay, so now remember, we don't only need the static frictional force, but we also need the normal force. So the normal force is actually on the vertical dimension. So if we want to calculate the normal force, we're going to look at the vertical dimension. And then also the object is not moving on the vertical dimension. That means the net force is equal to 0. So this will imply that the normal force is equal to the FG perpendicular. So to get the normal force, we will say that, okay, the normal force is equal to FG perpendicular. And we know FG perpendicular is equal to what? The FG multiplied by cos of theta. So now remember, FG is the mass multiplied by gravitational acceleration. But now we should use cos of 30 degrees. So this will therefore mean the normal force is equal. Let's punch that in our calculator. We just change there and put in cos of 30, and that is giving us the normal force of 127.31 newtons. So if we now have what? The normal force and the static friction, we should be able now to get the coefficient of friction. So I'm going to write the answers here to say now my static friction, it was equal 73.5 newton, and my normal force is equal 127.31. So 127.31 newtons, so that I can create a space and we do the calculations properly. Okay, so now that we have what? We have the normal force and we also have the static friction. We can now calculate the coefficient of that static friction, because the question wants the coefficient of the static friction. So what we will do now, we will substitute now the magnitude of the static friction, which is 73.5, which is equal to now the coefficient of that friction multiplied by the normal force, which is 127.31. So now if we divide both sides by 127.31, we should actually get now the coefficient of that friction. So in my calculator, if I say now 73.5 divided by 127.3, I get my static friction to be 0.57. So we get 0.57. So this is the coefficient of the static friction. That answers the question 2.3. So now as we move on now to answer the next question, which is 2.4. We should read the statement, because now the statement says now a horizontal force smaller than 20 newtons is now applied on the 15 kg block. Okay, so now I can erase here, because now this question does not need what we have here. So I'm going to erase. So I create the space and we just try to understand or try to make logic on what this question is actually looking for. So now they say now we now have a force, which is this force, and that force is less than 20 newtons. It is applied on the object. So now what is this force going to do on the object? Remember now, initially our free body diagram was having a gravitational force down, and then it has a static frictional force, and then we had the normal force. So now what we are doing now, we are including a certain amount of force. So if we include this amount of force, remember now this amount of force is now not parallel to the surface. It's not parallel to the surface. So this means now the surface is this one, and the perpendicular to the surface is that one. So this means now this force that is applied is going to have now component forces. It's going to have now a component force that is going there, and then another component force that is going on that direction. So that is what we know, that this force is actually going to actually make an impact on this block. Okay. So the question says, how will this change influence the magnitude of the coefficient of static friction calculated in 2.4? 3. So now what will happen to the coefficient of static friction? So the coefficient of static friction, it doesn't matter what is going to happen. Whatever the force we apply, the coefficient of friction, it actually depends on how rough the surface is. So we apply the force, we increase it, we decreases, but now the surface coefficient of friction only depends on the roughness of the surface. So this means now the coefficient of friction will remain the same. So to answer 2.4.1, we're only going to say, no. The coefficient is going to remain the same no matter what you do. So we're going to say this will do what? This will remain the same. So if you look at the next question, which is 2.4.2, they now say the normal force. What will happen to the normal force? Will it increase, decrease, or remain the same? And then you should explain your answer. So if we look at what we have, remember now the normal force, if we look at our component forces, remember the component force of weight was having weight perpendicular, or we can say Fg perpendicular and Fg parallel. So now initially the normal force was equal to Fg perpendicular, but now because of this force, the normal force is gonna be increased because now we're gonna have now the component force as adding up to that perpendicular gravitational force. So the normal force will now be equivalent to what? It will be equivalent to the vertical component force of that force of 20 newtons plus the Fg perpendicular. So this means now the normal force is going to increase. Is going to do what? Is going to increase. So now why is the normal force increasing? It's because now this force that you apply, it is going to have a component force that is perpendicular to the surface, and then that perpendicular force will actually affect what? It will affect the normal force because now it will be added to that gravitational perpendicular. So you can also just write this statement to say now the force is actually going to change the normal force in this way. So you can just explain it with the equation or try to put suitable weights. I don't know which weight exactly, but yeah, you will figure it out on the exam. Please just understand the concept and answer the way you think it should be. Okay, so now as we move on to the next question, on the next question, the statement says that two vehicles, A and B, are moving west on the straight line. I mean on the straight horizontal road. So we are given a direction to say the direction that they're moving in is west. So it's very much important to indicate the direction. So the statement continues to say now vehicle A has mass m and vehicle B has mass 2m. So this is also given to us. And then vehicle A travels at a velocity of 15 meters per second, while vehicle B travels as 10 meters per second. So we can also see that. The vehicles collide and stick together. So they are going to collide and they will stick together after the collision. So that is what we know. They will stick together. So the statement also says the total momentum of the system after the collision is equal to 35,000 kilograms meters per second west. And then we must choose west as a positive direction. So the last statement is telling us what? The total momentum, or the momentum of both the objects that are traveling together, it is going to be equal to the 5,000 after the collision. So that means now we can say the momentum after collision for both the object is equal to 35,000 kilograms meters per second. So that is given from the statement. And then all this other information is also given on the statement. So the first question, which is 3.1, it says we must state the law of conservation of momentum in weights. So we know the law says what? The total linear momentum in an isolated system is conserved. So that is how you define a conservation of linear momentum. So if we now look at 3.2, remember, please refer to exam guidelines for the definitions. So if we look at 3.2, they say we must calculate, and 3.1, we must calculate the mass of vehicle number A. So now, how can we calculate the mass of vehicle number A? We can actually use this that is given to us. We are told that momentum after the collision is equals to 35,000 kilograms meters per second. And then we also know that after the collision, this object are going to be what? Moving together. So that means now the momentum is going to be what? The momentum of the object is going to be what? The sum of masses. Mass of A plus mass of B multiplied by the velocity of the object when they are moving together. So that will be what? That will be the momentum that we know we have after the collision. So now, but now in this case, what will be the velocity of them after the collision? Do we know what is the velocity? So if we don't know the velocity after the collision, then we can use this equation to say now the momentum of them after is equals to that. Because now if we say that is equals to 35,000, we are not going to get the velocity since we have now two unknowns. We have unknowns of masses. We also have the unknown of velocity. So this means now we must use now the conservation of linear momentum. So what does the conservation of linear momentum say? It says now the momentum before the collision is equal to the momentum after the collision. So we know that before the collisions, the objects were separate. So we're going to say now the momentum of object A, which is mv for A, plus the momentum of object B, which is m and velocity for B, it is equal to what? To the momentum final. So what is the momentum final? The momentum final, it is given as 35,000. We know that the initial momentum will be equal to the final momentum because the momentum is conserved. So now in this case, we will be able to now calculate the mass because now we have the initial velocity, we have the initial velocity of both the object. So now we're going to substitute now what is going to be the mass of object A. Remember now the mass of object A is just given as m. So we're going to say now we're going to have m. And what is the velocity of A? That is going to be 15 meters per second. And now we know that it's positive because we choose west as positive. And then now what is the mass of object B? The mass of object B is 2m. So be careful. So the mass of object B is now what? 2m, not m. And then what is the velocity of B? The velocity of B is 10 meters per second. And that is equal to 35,000. So if we do our calculations, we should be able to get the mass of the object. So we're going to say m multiplied by 15, that is going to be 15m. 2 multiplied by 10, that is going to be 20m. And that is equals to 35,000. So 15 plus 20, that should give us 35. That should give us a 35m, which is equals to 35,000. So if we divide both sides by 35, 35,000 divided by 35, that should give us 1,000. So the mass of object A is going to be 1,000 kilograms. So that will be the mass of object number A. But now, if we were to calculate the mass of object number B, we will say that the mass of object number B is what? The mass of object number B is going to be 2 times the mass of object number A, which is 1,000. So that means the mass of object number B is going to be 2,000 kilograms. Okay, I'm just going to write now the mass of A here, which is 1,000. And then we create the space so that we will be able to answer other problems. Okay, so now that we have the mass of object A, which is 1,000 kg, The next question, which is 3.2.2, it says we should calculate the velocity of the combined vehicles after the collision. So now that equation I was talking about, we are now going to use it, because what do we know? We know that the momentum after is equals to that. And then after the collision, we are told the objects are moving together. So that means now the momentum after is going to be what? Mass of object A plus mass of object B, since they are together and they will be having the same speed. So we add the masses, we multiply them by the speed. That should give us the momentum after the collision. And the momentum after the collision, it was 35,000. So what we have to do now, we have to substitute the mass of A and the mass of B. So please be careful. The mass of A is 1,000, but the mass of B is 2,000, since we have now a mass of B as 2 times the mass of A. So we're going to substitute now the masses. We're going to say the mass of A is 1,000 and the mass of B is 2,000. And we are looking for that velocity after the collision, or the velocity of the combined. So that is going to be equal to 35,000. So 1,000 plus 2,000, that should give us 3,000 V final. And then this is equal to 35,000. So we divide both sides by the 3,000. We should get now the velocity of both the objects after the collision. So now if we put this in our calculator, we say 35,000 divided by 3,000. We get the answer as 11.67 meters per second. So both of the objects are going to go where? Are going to go to the west. So we're going to say now this velocity is 11.67 west. Remember, now you must indicate that direction. So that will be the velocity of the combined object after the collision. So I don't think we are going to need all this for the next question. So I'm just going to erase this just to create some space. So now we're going to now move on answering the question, but now we're going to first have to read this statement so that we can answer the coming problems. So now the statement says now, the following net force against time graph is given for all forces acting on vehicle number A. So, okay, this diagram, it represents the forces acting on vehicle number A, driving from a stop street until after the collision with vehicle number B. Okay, it's the very same thing. We have now a vehicle A moving and then colliding with vehicle B. But now this diagram that we have here, it is only a graph that represents the net force against time for vehicle number A. We should be able to realize that this diagram is only for vehicle number A. Okay, so the first question that we have, which is 3.3.1, they say explain what is the area represented by A. So if you look at this A here, remember area is length multiplied by breadth. So if you look at area 1, we should then say now this area is equal to what? The length should be what? The net force. And the breadth should be what? The time. So we have now the net force multiplied by change in time. So if we look at this, net force multiplied by change in time, that represents the impulse. So what we can do, we can say now, okay, this thing here is what? It is actually representing the impulse. Okay, but now remember now this net force multiplied by change in time, it can also be equal to the change in momentum. You can say this is representing impulse or it is representing the change in momentum. So both the questions or both the solutions that you give will be incorrect. So now the next question, which is 3.3.2, they say calculate the duration of the collision. So now we need to calculate the time the collision happened. So how can we calculate the time the collision happened? If we look at the diagram here, we have the force before this object is in contact. So before any contact, the force was 1000 newtons. But now, during the collision, the net force experienced by both this object is now negative 2000. So the net force during the collision, it is equal negative 2000 newtons. So in object A, it is negative. That means the net force on object A is going to go into the east. But now also the same amount of force. Remember now when they contact together, is going to have what? Same amount of forces in opposite direction. But object B is going to also experience that 2000 newtons, but now it will experience it to the west. So this is what the diagram tells us, but now it tells us about A. So it tells us about A that A is going to experience a net force of negative 2000. That negative simply means now it is experiencing a force to the east, since we are taking west as positive. So now that we know that object A is going to experience this amount of force. So if we have the force, how can we get now what we call the change in time? So remember now we can use the equation to say now, okay, the impulse says what? It says now the F net is equal, the F net multiplied by the change in time is equal to the change in momentum of the object. So if we use object A, remember we have now the initial velocity as 15, but we have the final velocity of both the object. So I thought we are not going to use that, but I still have that answer on the calculator. Yes. So the velocity of the both the object finally, it was how much? The velocity final, it was 11.67 meters per second, and it was going to the west. So that was the velocity of both the object after the collision, since they are going to move together. So now we can calculate the change in momentum of object A, since we have now the initial and the final. So the final is this one, the initial is this one right here. So we are going to say now the net force experienced by block A, or maybe car A, is going to be negative 2000. And then we have to get now the change in time. But now what is the change in momentum? Remember now the change in momentum is going to be momentum final minus momentum initial. So we know the mass is still the same, so we can take it out as a common factor, but you can just also do it like this. So you can say now you have negative 2000 as the force, you have change in time, and then what is the mass of the object? Remember now the mass of object A is 1000. What is the final velocity? The final velocity is to the west. It is 11.67 is positive minus what is the mass? The mass of the object is still 1000. And then we have to multiply it by the initial velocity, which is 15. It is positive because it is also going to the west. So now we have now negative 2000 multiplied by change in time. So if we add this together, we get that 1000. So I'm just going to put it into bracket, and then I say 11.67 minus the 15. And that is giving us negative 3,330. If we divide both sides by negative 2,000. So now if we put this in our calculator, we are going to say what? Negative 3,330 divided by negative 2,000. And that should give us the answer as 1.67 seconds. So this will be the duration of contact. This should answer now question 3.2. So now the next question that we have, which is now 3.3.3, They say that we must draw a rough, not to scale, momentum against time graph for object B, showing the shape of the graph before and after the collision. No values. Okay, so let's look at what is happening here. So if you look at object B, if we had now a graph of momentum against time, we will say now this is momentum and this is time. So initially, the car is traveling at a particular momentum, which is mass multiplied by that. So we'll say that momentum perhaps is just going to be a positive momentum there. Okay, but now this car here is going to be in contact with car A. So do you see now car A is going to increase the momentum of car B because it's hitting it from behind in the same direction. So car A actually increases the momentum of car B. So what is going to happen is that during the collision, the momentum of object B is going to increase and then it's going to remain the same after the collision. So this should be a diagram that you give for that question to just indicate, okay, momentum was initially here, and then during the collision, the momentum will increase and it will return to be a constant again. And that should answer question number 3. So now as we move on to question number 4. Question number 4, it says that a grain starts to lower a grade vertically downwards from a certain height. Initially, the grade is accelerated from rest and then moves downwards at a constant velocity. Okay. The velocity time graph below, not drawn to scale, represent the motion of the grain. Okay, so now remember now we have now the grade that was picked up by a grain. Okay, so it was picked up and it was picked up to a certain height. So the motion is represented by the diagram there. So the velocity will increase like that, and then now the velocity will remain constant, and we can clearly see now the velocity is increasing again. So with this information, can we now use this information to answer the question that is provided? So they say now 4.1, use the graph to determine 4.1.1 the time at which the grade starts to move at a constant velocity. So if we look at the diagram here, the time when we start to move at a constant velocity, it is going to be how much? That should be giving us a 0.01 seconds. We just read it from the graph. We take it as it is. So 4.1.2, they say now the magnitude of the grade's velocity at 2 seconds. So now at 2 seconds, 2 seconds is here. So at 2 seconds, the magnitude of the velocity is still constant and the magnitude is 4 meters per second. So that is going to be what? Just 4 meters per second. So that is how we answer those first 2 problems. So now the next question says now, use the graph to determine the magnitude of acceleration of the grade from 0 to 1.1 seconds. Okay, so now we want to determine the acceleration from this point here to that point. So if we are looking at the velocity time graph, acceleration is the slope of the graph. So by definition, if I can remind you, the definition of acceleration is the rate of change in velocity. So is change in velocity over change in time. So change in velocity over change in time, that means we have now the change in y over the change in x. That is what is happening here. So the gradient of the graph at those points whereby we have 0 and 0.1 seconds. So we should just get the acceleration by using the equation 2. So now we're going to say now, okay, the change simply means the final velocity minus initial velocity, all divided by the final time minus initial time. So to get the acceleration, we use the graph. So now look at this. This is the point here that is the point of the final. What is the final velocity at that point? At 0.01, the velocity is 4 meters per second. So we're going to say now we have 4 meters per second, but what is the initial velocity? The initial velocity is actually 0 there. So we're going to say 4 minus 0. But now what is the final time? The final time is 0.01 and the initial time was 0. So this means now we're going to use this equation to get now the acceleration of the object from 0 seconds to 0.01 seconds. So that's going to be 4 divided by 0.01, and that is giving us 400 meters per second squared. So that means now this crate is actually accelerating 400 meters per second squared. That's too much. Okay, so now we're going to continue now to answer the questions. We are now doing 4.2. So on 4.2, they say now the crate accelerated at time equals to 0 seconds. Now, is the crate a projectile during this acceleration? Write down yes or no. So that means that is going to be no. That is not a projectile. Remember, a projectile, it is only if we have a gravitational acceleration influencing whatever object we have. So that statement should just be no. That's not a projectile. So now 4.3, it says we must draw a free body diagram showing all forces acting on the crane at 2 seconds. So now at 2 seconds, remember it is at this point. And then at that point, what is happening? At this point, that is when now the crate was released. So remember now, let me just try to make an example. Remember now we have a crane. So a crane is something that has a hook like this. It is taking a crate and then it takes this crate up there, still connected to the crane, and then now the machine just starts to release the chain. So if it releases the chain, do you see now the weight of the crate will be going down, but now there's still going to be now the tension from the crane because the crane is still holding that crate. So there's going to be a tensional force from the crane. So if you now draw the free body diagram, you're going to say now on the free body diagram, we're going to have now what we have now. This is going to be the weight of the crate, and then you're going to have now the tension from the crane. This is going to be the tensional force from the crane that is holding that crate. So remember at this point here, at this position, that is when the crate was released. It was released at a constant velocity, if you have read the statement carefully. So that is the free body diagram that we have. And then now we have to now read the first statement before we can continue with the question. So this is 4.4. I'm just going to erase. Let me just erase so that we create some space. So now we are going to answer now 4.4. But before we answer 4.4, we should read the statement that is given to us. The statement says, after 3 seconds, the cable snaps. So now after 3 seconds, the cable snaps. So now when the cable snaps, what is happening? Now we are no longer having a grain on the crate. That means the crate now is on a free fall. So that means now it is not having anything attached to it, but it's just going down because of the gravitational acceleration. So from the time 3 seconds afterward, the crate is a projectile because now the crane or the cable of the crane, it has snapped. So now, and they say now, and the crate free falls. They even specify that it free falls. So it's the motion under the influence of gravitational force only. And then it hits the ground at t with the speed of this much. So it's going to hit the ground at t, and then the speed is at 32.5 meters per second. So the first question says we must determine the term free fall. So now free fall is the motion under the influence of gravitational acceleration only. So that is how we define that. So now we should answer 4.5. 4.5 says calculate the time when the crate hits the ground. So now we should calculate the time at this point. So we are using now equations of motion because now from time t till there, we are having a free fall. So the equations of motion will apply. So now what is happening, we have now the initial velocity is 4 meters per second, and we have the final velocity as 32.5 meters per second. So we have the initial velocity and the final velocity. We also have the acceleration, because now this is a free fall. That means the acceleration is 9.8 meters per second downwards. So to get the time, that means we can use the first equation of motion that says what? The final velocity is equal to the initial velocity plus acceleration multiplied by change in time. So every time when you use these equations of motion, you should indicate the direction. So remember now, this crate is going downwards. So you can just take down as positive, or you can take up as positive. It depends on you. I don't know if they said we must take up as positive. No, they did not mention that. So this means now we can choose now to say now downward is positive, since our crate is going downwards. So we can just put that as positive. Okay, so now what is the final velocity? The final velocity should be now 32.5, which is positive because it's going down. And then initially, it is also 4 meters per second because it was also going down. So now the acceleration should also be what? 9.8 meters per second squared, because it's going down. It should be positive. And then now this is changing time. So if we transpose the 4 to the other side, we are going to have now 32.5 minus 4 being equal 9.8 change in time. So if we put on our calculator 32.5 minus 4, we get 28.5 equal 9.8 change in time. So if we divide both sides by 9.8, we should get now the change in time, which is 28.5 divided by 9.8. That is giving us the change in time, which is 2.91 seconds. Okay, so now this is the change in time that we get from this point to that point, 2.91 seconds. But now remember, the question said we must calculate the time at t. So the time at t should be 3 seconds plus that, because now we have to add that 3. We did not neglect that initial motion that happened. We just have to now add the time, and then we get now the time at t. So this will mean now that t is going to be equals to 2.91 plus 3, which should give us 5.91 seconds. So the time at t should give us 5.19 seconds. Okay, so now we have that time there. Let me just write the time here so that we see now if we can erase things. And let me just say that t there, it is 5.91 seconds. Okay, so if we can erase this so that we create some space and try to answer the next question. The next question says, calculate the initial height of the crate. Okay, so that means now we are not going to need this, because now we are going to use the diagram to actually determine the initial height. So what is going to be the initial height? The initial height is just going to be the area under the whole curve of this velocity diagram. So the area under the curve. So what do we have? We have now the first area, which is this area here on the triangle. Okay, so we're going to say now the height should be the sum of what? Of the first area, that is area 1, the one that I'm highlighting there to you. And now we're going to have area 2, which is this one here, which is the rectangle. We're going to say we have plus area 2. And then now we're going to say now we're going to divide this part here to say now we have now the area 4, 3 there, and area 4 there. So this is 2, that is 1, that is 4 there. So we're going to say now plus area 3 plus area 4. So remember why I'm using this to determine the height. We have now the velocity multiplied by time as the area of the velocity time graph. So remember, velocity is given as meters per second. So if you multiply by time, which is seconds, you are going to get meters. And the meters will represent the displacement under the area of a velocity time graph. So that is why I'm using this to actually determine the total height of the crane. Because we can't use equations of motion. At this point here, what was happening is that the object was under the influence of the force of the crane, and then it was released, a lot of stuff. So we can't actually use the equation of motion to determine the height. So what we can do now, we can just use the areas under the curve. Or if we use the equation of motion, maybe it might be complicated. So now the first area is going to be this triangle here. So remember now, if you are looking for the triangle, you use now the area of a triangle, which is 1/2 base multiplied by height. And then now the area 2 is going to be this one. Area number 2, remember now that is just a rectangle. So we can just say area number 2 will be length multiplied by breadth plus area number 3. Area number 3 we also said, okay, this is just going to be the rectangle there. So area number 3 should also be length times breadth. But area number 4 is going to be this triangle here. So that should be what? That should be 1/2 breadth by height. So now we should substitute what we have. So now for area number 1, we're going to say this is 1/2. So the base is just going to be from 0 to 0.01. So that means the base is 0.01. And then the height should be 4. The height is going to be 4. Okay, that is the base and that is the height. So now for area number 2, now what is going to be the base? The base is going to be 3 minus 0.01. Remember, it should be careful. It's 3 minus 0.01. The distance from there to there is 3 minus 0.01. So we're going to say this is plus the 3 minus 0.01. I'm just going to put it as it is. 3 minus 0.01. And then we multiply this by the height. The height should be that 4 there. So the height is 4. Okay, so now we're going to add now area number 3. Area number 3. Remember the time at this point here. The time we have calculated the time to be 5.91. Okay, so now we already had the time from there to there, which was 2.91. Okay, so now if you want now the area number 3, we can see now, okay, from here to there, that is 2.91. So we don't have to worry about that. So we can say now the length is 2.91. But now what should be the height? The height from there to there, which it is also 4. So we're going to say also multiply by 4. And then we are going to add now the area at the top, which is the triangle. So that is going to be 1/2. So the base is how much? The base is still this time, which is 2.91. And now what is going to be the height? The height is going to be from here to there. So that should be 32.5 minus 4. So we're going to say that is 32.5 minus 4. And then now if we put all this into the calculator, we should be able to get the total height of the crane. Okay, so let me just put this in my calculator quickly. So we have 1/2 into 0.01 into 4 plus 3 minus 0.01 into 4 plus 2.91 into 4 plus 1/2 into 2.91 into 32.5 minus 4. And that should give us the total area. So the total area, which is the height, is going to be 65.09 meters. So this is the height that we get for the crate, the maximum height, okay, or the initial height. Okay, so now as we move on now to answer question number 5, what do we have to say? We have to say now, look at the statement. They say now, consider the organic compounds A to D. So we have compound A. So by looking at compound A, we can clearly see that is a haloalkane. We have now a pentane, and we have now halogens. So that's a haloalkane. If you look at compound number B, we have 8 carbons and 18 hydrogens. So remember now, for alkanes, that should be the number of carbons should be 8, and the number of hydrogens should be now 2 times 8 plus 2. And that makes sense because 2 times 8 is 16. If we add 2, that's 18. So this means number B is an alkane. The number C, what we have a ketone, since we have the double angle, but it's not on the first carbon. And then on number D, we have a very, very long chain structure with branches. Yeah, but we will look at that when we get there. So now, the first question, which is 5.1, it says for compound number A. Remember now, compound number A, we know that is a haloalkane. They say, write down the general formula of this homologous series. So remember now, the general formula of a haloalkane is CnH2n minus 1, and then you just put the X there. That is a general formula for that homologous series. So now, if we move on to 5.1.2, they say, is this compound saturated or unsaturated? So if you look at haloalkane, it only has single bonds. So if something only has single bonds, that means it is saturated. It does not have the ability to take any other hydrogens or maybe halogens. So it's saturated. So now, as we move on to now 5.2, 5.2, they say now, compound C has 1 positional isomer and 1 straight chain functional isome. So they talk about number C. So remember now, when we talk about the positional isomer, that means this double bond, it can move on the middle bond or on the last bond. But now once it moves to the last bond, that's going to be the functional isomer, because if it moves to the last bond, it becomes an aldehyde. At the moment, this is a ketone. So they say now we should give the name of the functional group found in C. So remember now, the functional group found in C, it is given as what? As this. But now, what is the name of this? So if you look at this, we have what? We have oxygen and carbon. So for us to actually name this what we call functional group, we say the name of the functional group is carbonyl. You should be able to name all these functional groups. Please just try to memorize all the names of the functional groups if possible. So because I see now we have a double bond oxygen, and then the other carbon is bonded to other carbons. So that is why we name it to be carbonyl. Carbonyl, yeah, that's like that. So now, as we move on to 5.2.2, they say we should draw the structural formula of the positional isomer. So now, the positional isomer of this, it's just going to move to the middle part here. It's only going to move to the middle part. Because now, if it moves to that part here, it's still going to be the same, because that means now your chain will have to start on this side. So it will still be on position number 2. So the positional isomer, it should only be when we have the double bond in the middle. So you're going to say the positional isomer is going to be, we still have what? A 1, 2, 3, 4, 5 carbons. But now we just move that to this carbon here. Remember now, if you move it to this carbon, that was going to be incorrect, because it's still the same as if it is on that carbon. So what you should now indicate is the hydrogens. You should also put your hydrogens, and to show that you have a complete structure. So that should be the positional isomer of C. So 5.2.3, they say we must give an IUPAC name of the functional isomer. So remember now, when you talk about the functional isomer, this was a ketone, so the functional isomer should be an aldehyde. And now that means now on the functional isomer, this thing is going to be what? On the first carbon. So if it is on the first carbon, for aldehyde, we just count the number of carbons. That is going to be 5. So that means if it is 5, that means it's what? 5 means what? Means pent. And then if it is an aldehyde, we just say that is going to be pentanal. So the name of the functional isomer should be pentanal. Okay, so that is how we answer that. We are now moving on to 5.3. So I'm just going to erase here so that we can have the diagram, because we need this diagram to answer the questions. So now if we look at now the next question, which is 5.3, they say write down the IUPAC name of compound number D. So now for us to be able to write the IUPAC name of compound number D, we should be able to throw it down first. So if you look at compound number D, for the first carbon, we have 3 hydrogens. The second one, we have 2 hydrogens. The third one, we have 1 hydrogen, and we have a chain of 2 carbons. Okay, that should be like this. And then now we have now the next carbon being with 2 hydrogens. And now the next one being with 1 hydrogen and a double bond. I mean a branch with double carbons. And then now we have now the last one, the next one with 2 hydrogens, and the last one with 3 hydrogens. So this is the structure that we have. So now if we should label the structure, we should find the longest chain. So if I look at this now, I'm going to have 1, 2, 3, 4, 5, 6, 7. That's one chain I see. Let me see if I do it like this. 1, 2, 3, 4, 5, 6, 7 is still 7. So that means now the 7 is going to be the longest chain. Whatever way I go, I have 7. So that means 7 is the longest chain. So I can just take this as my longest chain to say this is my 1, 2, 3, 4, 5, 6, 7. Because I just decided to choose that. You could have choose that this one of the green dots. It is really up to you. But now remember, you should always look at the longest chain. So now from this longest chain, I'm going to also see now if I label it on this side to say now I'm going to start on this side. If this is my 1, 2, 3, 4, 5, 6, 7. Which side I'm having the branch closest at the smallest number. So I can see on this side, the first branch is on the 3, and then also if I come on this side, it's on the 3. So it really doesn't matter which side I come from. So what I should do, I should now name here. I have now the branch at 3, and I have the branch at, this is 3 and 5. So I should say now, I have now the branch at 3 and 5. But now what is the branch? The branch is 2 carbons. So if it is 2 carbons, that is going to be diethyl, because eth means 2 carbons, so that is going to be diethyl. And then we have now 7 carbons in the long chain, so that is going to be 7 means what? Hept. So that's going to be diethyl heptane. Okay, so that should actually name that. Then we are done with that. So now we are going to move on now to the next question. The next question, which is 5.4, they say now compound B reacts at the higher temperature. Okay, remember, after we name that, we should get the structure. Remember now compound B, okay, that was not necessary because now compound B, it is already here. So they say now compound B reacts at the higher temperature and pressure to form a 4-carbon alkane. Okay, so we are told that this carbon number B, which is C8H18, is reacting at high temperature and pressure, but now the P is going to be now an alkene with what? With 4 carbons. So we know that it's going to be 4 carbon maybe the double bond is just going to be, I'm not sure where it is. I'm just assuming maybe it's going to be there. But I know it's going to be an alkene. Alkene, where's the double bond? I don't know. So I'm just assuming it is there at the middle. So that is P. That is what we are told. We are told that P, it has 4 carbons and is an alkene. And a straight chain of an alkane at Q. So that means now alkane should also have 4 carbons, because now we have total of 8 carbons. So I should just draw this thing to say now an alkene will also have 4 carbons, but now that should be just only hydrogens bonded, because that is an alkane. Okay, so the first question says, write down the type of reaction that takes place. Okay, so now if we have long chain alkanes and then we break them down into small chain alkanes, we call that kind of a process or a reaction a cracking. So you can just say now this is a cracking. Okay, so now 5.4.2, they say now, write down the structural formula of the chain isomer found in D. So we know now on D we just have the straight line butane. So what will be the chain isomer? The chain isomer is just going to have 4 carbons, but now it will be branched. So it's just going to be 1, 2, 3, and then we just branch it there. So that should be the isomer of that butane we have as the product there. And they said we must draw the structural isomer. Okay, so now 5.4.3, it says we must write down the molecular formula of compound P. So what is the molecular formula of compound P? Compound P, it is having 1, 2, 3, 4 carbons. So that's going to be C4. Because now this is an alkene, I know that hydrogen is just going to be 4 multiplied by 2, which should be 8. But you can count there to check now how many are there. 1, 2, 3, 4, 5, 6, 7, 8. So we have now this as what? As the molecular formula of compound number D, C4H8. Okay, so now as we continue now, we have now question number 5.5, and it says that a carboxylic acid molecule has mole ratio of the carbon, it is having 3.3 mole, and then hydrogen is having 6.67 mole, and then lastly oxygen is having 3.3 mole. So now the first question says determine the empirical formula. So if you want to determine the empirical formula, in this case, this is already simplified because you're already given the number of moles. So if we have the number of moles, we're just going to say what we have. We're going to look at the ratio in between carbon, hydrogen, and oxygen. So we're going to divide everything here by the lowest number of moles we have. And then the lowest is just going to be 3.3 there. We're going to divide everything by 3.3, 3.3. So if we say 3.3 divided by 3.3, that means now the ratio of carbon is just going to be 1. But now what should be the ratio of hydrogen? If we say now 6.67 divided by 3.3, that is giving us 2.003, that's 2. Okay, and then last one, that should be 1. 3.3 divided by 3.3, that should give us 1. So that should be now the empirical formula, which we just gonna write it to say now we have 1 carbon, and then we have 2 hydrogens, and we have oxygen. So that should be our empirical formula. So now the next question says, if the molar mass of the compound is 60 grams, now you use your calculations to prove that this is ethanoic acid. So we are told that the molar mass of the compound, remember now the compound that we have is this one, but now they told that the molar mass is actually 60. So now we need to check now what is the molar mass of CH2O. So we're going to use now the periodic table to say what is the molar mass of CH2O. So now we're going to add all the molar masses. Remember now when you talk about the carbon, it has a molar mass of 12, plus we're going to use the molar mass of hydrogen, which is 1, but now we have 2 hydrogens, we should multiply by 2. And then we should also add with the molar mass of oxygen, which is 60. So now if we add all these together, that means the molar mass of this empirical formula, it is given as 30 grams per mole. So now we are told that actually this compound, it is having 60 grams per mole. So do you see now, this compound should be multiplied by 2 so that it can have what? It can have that 60 grams per mole. So if you multiply that by 2, you're going to have C2H4O2. And then this, it represents now what they said we should actually prove, which is now ethanoic acid. Because now this thing can be represented on a structure as a 2 carbon, and then what we have 4 hydrogens, but now we have now 2 oxygens. So the one oxygen is going to bond there, and the other oxygen is going to bond there. So this is an ethanoic, because now we have those 4 hydrogens, we have the 2 oxygens, and that actually proves that is an ethanoic acid. So we can just prove it by doing the calculations to say the ratio is 1:2, and then we write this. We can also draw that just to prove them that is an ethanoic acid. So now after we are done, they say now draw the structural formula of the functional group of the ethanoic acid. So now they just want the structural formula of the functional group of the ethanoic acid. So remember now that functional group is just going to be at the carbon that is having double bond, and then we have OH, and that's it. So that is going to be the functional group. That answers 5.5.3. So now we're going to look at the last question. On the last question, they say now a group of learners were investigating the intermolecular forces and physical properties of various organic compounds. As part of their research, they determined the boiling point of 6 different compounds represented by letter A to F in the table below. Okay, so if you look at the table, we have now different compounds from A to E. So I don't know if this is F or what. I mean, it was supposed to be E there. And then we also have now the molar masses, and then we have the boiling points. Okay, so the first question, which is 6.1, they say we must define the term boiling point. So remember now, the boiling point is a temperature through which a liquid changes to a vapor. So a liquid substances, it boils and it becomes a vapor. So that is the temperature at which now liquids changes to a vapor or a gas. Can define that. Remember, you can also look at the definition at the exam guide. So 6.2, they say that compounds A and B have different boiling points, even though they belong to the same homologous series. Explain the reason. So now, if we look at compound A, we have methyl propane. So let's just draw the structure of this, because with the structure, it's easy to see what is happening. So 6.2, we have methyl propane. So that means now we have 1, 2, 3. So methyl should be on this carbon, because it can be on the first carbon. If it's on the first carbon, that is still butane. So the chain is on that carbon. You can say this is 2-methyl propane, but it's not necessary. You can write it as also a methyl propane, because there's no any other point the chain can be. And then now number B, we have now 4 carbons. So we have that. Okay, so now we can clearly see now, okay, the intermolecular forces of B are stronger than the intermolecular forces of A, because now B, it has a larger surface than A. So remember now, if it is branched with the same amount of carbons, it's going to have now less intermolecular forces. So we are going to say now B has stronger intermolecular forces than A. Why? Because B has a larger or a bigger surface area. You can just say it has a big or a larger surface area. Surface what? Surface area. So now, if it has a larger surface area, that means it's going to have what? Stronger forces. But now remember, in both the cases, these are alkanes. They just have strong London forces. Strong London forces. Okay, so that means now B has stronger London forces because of the strength. So if that is the case, then you can just conclude that that is why B has the higher boiling point than A. So if you look at this thing here, it is actually indicated on a diagram here. That is B, that is A. So B, it is having the higher boiling point because now it has a bigger surface area. The bigger the surface area, the larger the surface area, the stronger the London forces, and therefore the higher the boiling point. Or you can say now more energy is needed to break the bonds on the larger surface. It depends on how you would answer that question. Okay, so now we should continue now to number 6.3. So if you look at 6.3, they say now explain why compound C and E have different boiling points. Compound C and E. So let's just compare C and E. C is this one, and E is that one. So C is propane 1-ol, and then this one is ethanoic acid. So now we are comparing alcohol and ethanoic acid. So they say now explain why compound C and E have different boiling points. In your own explanation, refer to the strength of intermolecular forces. So now we are going to say now, remember now E is what? Is our carboxylic acid. Remember E is the strongest. Why? So we are answering here. We are going to say now in compound E, we have hydrogen bonds. Remember now this is ethanoic acid. We have hydrogen bond occurring in two places. We have hydrogen bonds in two places. You can just simplify it to be like that, in two places. And you will say now, and in compound C, in C we have hydrogen bond in one place. In one place. So now what does that imply? This implies now number E, it has stronger intermolecular forces because now it has double bonds taking place in two different sites. Okay, so we're going to say now E has stronger intermolecular forces than C. Intermolecular forces than C. Why is that? It is because now E it is having hydrogen bonds in two places. So after you mention that E has a stronger intermolecular forces than that because of the hydrogen bond, you just specify that it is we're gonna need more energy is needed to break bonds in E than in C. So that should be 3 statements that should give you that 3 marks there. Okay, that's perfect. Okay, so now I'm gonna erase this, and then we answer now question 6.4. So 6.4, they say now identify the compound with the lowest vapor pressure from the table. Write down only the letter. So now remember, now the compound with the lowest vapor pressure, it is the compound that has the highest boiling point, or the highest melting point. I mean boiling point. So now which compound it is having the highest boiling point? That compound should be E. So compound E is the one that is having the lowest vapor pressure. So we should say now E, because E, it has the highest boiling point. The higher the boiling point, the lower the vapor pressure. So now 6.5, it says in comparing the boiling points of C and D, let's look at C and D. C is this one and D is that one. Is it a fair comparison? Yes, it's a fair comparison, because now you see, now we have alcohol there. So that is, yes, it's a fair comparison. And 6.6, they say now give a reason why that. They are both from the same functional group. They are both from the same homologous series, from the same homologous series, or they have the same functional group. So that's a fair comparison. Okay, guys, thank you very much. This question paper, it took longer than expected, but I hope you learn a lot from it. Thank you, guys. See you next time.